I tried transferring motion from the character in a video to the character in the image. And it works.
And that'll be okay because we're gonna know. And that'll be okay because we're gonna know what school she's in, and we're gonna know she's happy and she's got birthday parties and she smiles every day and she has sleepovers.
The motion is not completely accurate in this case because it's not a human figure, but it should work on a human-like character. These are the few extra frames that can be removed. Overall, it works, and the video generation time is also around 100 seconds for a 512 pixel video. Upscaling in the second stage takes 80 seconds more for a 1080 pixel video. The graphics card I am using is the 5060 Ti, 16 GB. In this case, the given image is shorter than the reference video, which resulted in some creativity by LTX. Modifying the prompt can remove the woman's hand. I cannot play the audio due to copyright protection. The audio and lip movements are not bad. You can check the results by visiting the link in the description. Let's look at the workflow quickly. So this section of the workflow has the model and LoRA selected. The prompt is also typed here. There's also a prompt builder here. When activated, it will enhance the simple prompt given by us. This section also contains the image we want in motion. In this section, these two nodes were just for testing. So this section contains the reference video for the motion. DW pose is extracted from the reference video, which is used further. This section is for the audio, and there are 4 types of audio we can choose to have in the final result. I will explain this ahead. This section in the center creates the empty latent video based on the DW pose received from below. The empty latent video can be the size of the reference video or the character's image. We will look at that ahead. In the same section, we have the K-sampler processing the video. The output from the K-sampler goes to the second stage, which upscales the video. The upscaled video is then decoded into a pixel video for us. Here, I have written that this second stage gave a black screen on my 5060 Ti 16 GB. Use the above node group if you get a black screen. The problem could be with my system itself due to a driver issue. You can try processing a 15-second video to find out. So instead of using this, I was using the nodes above, and this is the upscaled video. The video output is a 1080 pixel video. I am not using this anymore, though this is better. The output from the first K-sampler is visible here, a 512 pixel video, and the upscaled output is above. Now, if you want to avoid errors and do not wish to struggle like a beginner, then you should watch the workflow explain in detail. The model used here is MX-FP8. This works better on a Blackwell graphic cards. I have added the link to all the models, and if you are running a 4000 series or older card, then I suggest using this FP8 file. The MX-FP8 will work, but I have not tried it on an older card. This distilled LoRA has to be used if you are using the base model of LTX. Next is an IC LoRA node. This Really's Dance LoRA was uploaded by Kajai on Hugging Face. The LoRA link has been given above, and this is the file that uses the DW pose to transfer the motion. Next is the prompt, which is connected to the prompt enhancer. Turn this switch to true, and the prompt enhancer should work. The output is visible here, and the same goes into the text encoder below. The dual clip loader takes 2 files, and links to both files are given on the left. The image we want in motion is below, and it has been resized. The resolution you see here works, but there are some sizes that won't work and will give an error like this. The proportion is set to resize, so the image is resized by maintaining its aspect ratio. In case the character appears small in size due to a large background, you should change this value to crop. The image will be pre-processed so that it can be used more efficiently further. The video uploaded here is being resized to 512 pixels. You can go even lower, like 448 or 416. Then it goes to this DW pose estimator, which is from a custom node group installed. The pose extracted is then brought back to the given size, which goes ahead in the workflow. The pose extracted is visible here, but if you do not want to install this custom node, then there is a natively supported node below, which does the same job. This node will need a safetensor file, which can be found on Hugging Face. The link to the file is given on the left. Get the file, make this connection, and you can delete this node if not using it. The DW pose preview will be visible here, which is saved in a folder named Trash inside comfyUI's output folder. I have connected the node to show you the output, and it takes time. On the first run, it took 150 seconds, but it should be faster on the second run. The difference between these two poses is not much. The pose extracted is then used, along with the empty latent video, to create the video latent in the LoRA node. The resolution of the empty latent video is taken from the DW pose we saw below. But we can also use the image resolution to have the same aspect ratio. This total count is the number of frames we got from the video. The same will be the length of the video in the result. So, using the DW pose and the image, the video latent is prepared. Now, about this audio latent, which has a connection from the node group below. And there are 4 nodes to get audio from. The first connection brings the audio from the reference video, which goes above. The second connection allows you to upload an audio file, which can also be a speech. The lip sync will work, but remember the character will be restricted due to the DW pose. Make the connection, and the audio file will be used. The third is the empty audio. In case the reference video you're using has no audio, then you have this connected. Otherwise, you will get an error. The fourth option here is about the empty latent audio. Connecting this will let the LTX model generate some audio. All this audio is connected to the trim node or the FPS node, which should adjust the audio to match the video's length. When the video is generated from the first K sampler, it is supposed to be processed again in this second stage. And the final result should be visible here. But I'm not using this second stage workflow. I am using the one above. You can activate this and use it if it does not give you any problems. Make sure to bypass the above nodes if using the nodes below. There is a safetensor file used here to upscale the video, and a link to the file will be added later. I have uploaded this image, and I will crop it to get the character's image. To check the output, I have bypassed all the nodes responsible for generating the video. And the image now looks fine. I will let the other things be the same, activate this node, and then run the workflow. The video from the first stage was generated in 112 seconds, and this is the video. The result generated is good. These black frames can be removed, but I will process the same in the second stage, and these frames will be fixed. Activate the second stage node and run the workflow. The process started from here, and the time taken for this 12-second video was 68 seconds. The result generated was fine, and the audio matches the movements of the character. Similarly, you can use the aspect ratio of the image. The cropped image with an odd resolution gave me an error, so I am changing the value to 384 and ran the workflow. The result was now generated. Now activate the second stage to upscale the resolution. It took 95 seconds, and this is the result. The final result is around 800 pixels because I had to decrease the image size. But I could also have managed with a cropped image, using it again and resizing it to 512 pixels. So that was it in this video. I hope the video was informative. I wish you an excellent day.